1 to 9.3 conversions notes. We're going to do a couple examples that I left for you to do after class. So in class, we should have already gone through these first two examples, and we're going to look at this last one, the 79 ounces to pounds. So for this, just like always, I'm going to take this first number, this 79 ounces, and put it over 1 to make it into a fraction. And I want to multiply by a unit fraction. So something that is equal on the top and bottom, but has different units. So I want to go from ounces to pounds. Remember, I want like units to be diagonal from each other, so they will cancel out. So I know, because I'm trying to cancel out ounces, I need to have my ounces in the denominator. And because I want to get to pounds, the pounds has to be in the numerator. And the way ounces and pounds are related is that there are 16 ounces in 1 pound. That is how I set up my multiplication. Now, whenever I multiply fractions, I multiply straight across. So when I multiply my 79 times 1, I get 79. When I multiply 1 times 16, I get 16. So I have 79 over 16 pounds, because these ounces cancel out. But most of the time, we're asked to give these answers in decimal form. So remember, this fraction bar really means division. So I'm going to do 79 divided by 16. And if I do that, I get 4.9375. And my units stay pounds. The next example we're going to do together is the last one on the page where we were talking about converting with our metric system. So we have 8.4 milliliters, ml, to deciliters, dl. So whenever we're converting within the metric system, I always start out using my acronym King, Henry, died, Monday, drinking, chocolate, milk. Remember, this middle M is where we put our meters, our grams, and our liters. It's our base unit. So when I look up at the problem, it's milliliters, deciliters. So I want that L for liters, not the G for grams, and not the M for meters. And I go through and put an L after every prefix. Now, I look at the number they gave me to start with, the 8.4 milliliters, and I write it underneath my milliliters. They tell me that I want to get to deciliters. So to get there from milliliters, I need 2 steps to the left. So what that tells me to do is take this decimal point in my 8.4 and move it 2 spaces to the left. And we fill in that blank space with a 0. So we'll have 0.084 deciliters. The next example we're going to look at is the last one on the next page. We're going to use dimensional analysis to go back and forth between the US system and the metric system. So if we look at this example, they are asking us to go from 7 pints to liters. The issue is there's no direct conversion from pints to liters. So there's 2 ways that we could approach this. Because the only way to get to liters from the US system is to get to quarts first. So what I could do is focus on my 7 pints and put it over 1. And first change my pints to quarts. So if I do that, I'll have 2 pints 1 quart. But I don't want to have to do 2 separate problems. So I'm just going to keep going with this problem. And I'm going to convert from quarts to liters now. Now I still want my quarts in the denominator because I want those like units to cancel out. Now there are 2 different conversions to go from quarts to liters. You should have on your paper that 1 quart equals 0.95 liters, or that 1.06 quarts equals 1 liter. Now we can use whichever one we want. And like we talked about in class, it's usually easier to use whatever's going to put a 1 in our denominator. So we want the 1 to be next to quarts. And with those conversions, that means we want to use 1 quart equals 0.95 liters. If we do that, we can multiply straight across. So we'll do 7 times 1, which is 7, times 0.95, which gives us 6.65. In our denominator, we have 1 times 2, which is 2, times 1 again, still gives us 2. And if we double check our units, the pints cancel out because they're diagonal from each other. The quarts cancel out because they're diagonal from each other. So we're just left with liters. Just like before, we know that our fraction bar means division. So we do 6.65 divided by 2 to get our decimal answer of 3.325 liters. And that is not quite the last example. We're also going to look at this one, where we find the area of a rectangle in meters squared with a length of 13 feet and a width of 9 meters. So just like before, I'm going to draw out a rectangle. And it tells us in this problem that our rectangle has a length of 13 feet and a width of 9 meters. So I'll say 13 feet, 9 meters. If we look back for what they're asking us to find, they want the area in meters squared. So because we want our final answer to be in meters squared, we need to convert our 13 feet to meters before we can do any other calculations. So I'll take my 13 feet, put it over 1. I'm going to use my unit analysis or dimensional analysis. I know I want my feet to cancel out, so I put feet in the denominator. I know I want to get to meters, so I'll put my meters up top. And just like before, I want my 1 for the feet to go in the bottom. That conversion is that 1 foot is 0.30 meters. If we multiply that out, we have 3.9 meters. So that is not our final answer. What it tells us is that instead of 13 feet, we can use 3.9 meters for that length. Now we can find what they actually asked us. They asked us for that area. And remember that formula, the area of a rectangle is length times width. So we'll have 3.9 meters times 9 meters from that original problem. And when we multiply them out, we get 35.1 meters squared, or 35.1 square meters. You could write it either way. That is our last example for this section of notes.